Hey Jamie, hand me that soda over there. I'm thirsty. Oh, but I hate warm soda. I'm gonna go into the freezer and try to cool it off a little bit.
Wait, haven't you ever heard what happens when you put soda in a freezer?
No, why? What happens?
Well, it explodes and it makes a big mess everywhere.
So you're saying if I put this in a freezer, it's gonna explode? That's a perfect myth to test. Why don't we grab an ice chest, put some dry ice in it, put the cans in it, and simulate a freezer situation?
Yeah, it should be a blast.
This experiment is called Soda Pop. The myth for this experiment is that soda kept in the freezer too long will cause it to explode. We will be using both a soda can and a soda bottle. In order to test this, freezer conditions will be simulated by using an ice chest. For cold temperatures, we will use dry ice, which is solid CO2. It can undergo a phase change from a solid to a gas called sublimation. It is solid at a temperature of about a chilling -109 degrees Fahrenheit. The ice will be placed in the box along with the soda can. The cool temperature of the ice will bring the temperature of the can down and its contents down. Additionally, soda is comprised of about 90% water. When water is frozen, the water molecules form a rigid crystalline structure. This structure takes up more space than free-moving water molecules. The prediction is that this ice expansion will be greater than the volume of the can and cause it to explode. There will also be a soda bottle placed in the ice chest. The soda bottle, however, is made of plastic. So as the water freezes and the crystalline structure expands, we predict the bottle not to explode due to its flexibility. Lastly, we will equip the lid of the ice chest with a light and a camera to capture all the action.
Alright, so for this experiment, we made a mock-up freezer here. We filled it up with dry ice. Dry ice has a temperature of -109 degrees Fahrenheit, whereas a typical freezer has a temperature range from 20 to 30 degrees Fahrenheit, but we're going to kick it up a notch for this one.
So in this experiment, we are taking a can of soda and also a bottle of soda. We're going to place them both in the dry ice and see which ones are going to explode first. Our prediction is that the can will explode first because there is no room to expand, whereas the plastic has room to expand. Folks, do not try this at home. We are trained professionals, which is why we have gloves and goggles on.
Yeah, with dry ice you want to be particularly careful because it is solid CO2 and it sublimates quickly at a very low temperature into a gas, and without the proper gloves you can get frostbite.
To catch all the action of the cans exploding, we have a lid set up here with the camera on top. You can get a great picture of the overhead shot of all the cans exploding. So as you can see, the can exploded, making a mess everywhere. So when the water inside the soda freezes, the molecules form a crystal lattice, causing the can to expand past its volume, making it explode.
What's interesting though is that the bottle remains intact, and although it expanded, the flexibility of the plastic was enough to withstand the change in volume. So what do you say that this myth is
Confirmed. Yeah!
Yeah.